In the last video, we talked about how to read data of transactions into R, use the arules package. And in this video, we're going to talk about different measures of association rules. And there are different measures that we can use to describe how interesting those different rules are so that we can select the most interesting rules from all possible rules or items set from the data. And the first interest measure that is important to know is called support. And the idea is pretty simple. The measure of support basically captures how frequent a specific rule happens in relation to the total number of transactions. For example, if we care about, if we want to ask a question, how often is the course political science selected in the data set, you just find those transaction that contains that course and divide that with the total number of transactions. So you get the support of that particular rule. And in some cases, you have the combination of different courses or different items. So you just need to find how those different combinations, how that particular combination occur in relation to the total number of transactions, right? In this case, using this example you see here, this is a list of 5 different transactions with different courses selected for every transaction. And the support of the combination of political science and psychology, it happens only once in the 4th transaction. So the support for this rule is 1 divided by the total number of transactions, 5. So the support is 0.2. So again, the idea or the concept of support is trying to describe, given the total number of transactions or cases, how frequent they are appearing in this data set. And then the next measure, because support is very basic, it can be very, it's only focused on the frequency and popularity. We have a combination of different things together. The support doesn't really tell too much about how interesting the rule could be. So the next measure that is called confidence. It tells us how likely an item Y is purchased or appears, even item X appears, right? So this is considering how popular item X is already in this list of transactions. And so this, again, using layperson language, this is asking how confident we are about this rule, given the probability of X appearing, right? It's adding another layer of consideration beyond support. Again, I think the best way to illustrate this is to think about this example here. We have 5 different transactions. We already know the support of political science, of psychology, and about the combination of both of them. And the confidence we have about political science and psychology as a frequent item set can be computed through using the support of the combination, and then divided by the frequency of X, which is the frequency of psychology here, and then we get the confidence we have about having this item set or this rule from this data set. So, and using layperson language, the confidence, or if we see a high confidence, such as maybe 0.9, 0.8, that's a really high confidence, that could mean this rule is often correct, or we have confidence in this rule if we see a high value of it, versus we have a lower value of this, we're not so confident, because if we factor in the frequency or the support of a particular item, we're losing that confidence, even though this rule can have a high support. But if we factor in that variable, we become less confident about this rule. And the measure of confidence still have some challenge because it's only considering how frequent or how popular one item is. It doesn't really care about another item. So there's another measure which is called lift. Lift tells you how likely item Y is purchased when item X is purchased, while controlling for how popular both items are. Using the same example here, the lift of political science and psychology, those two courses, we need to add another measure here to be divided, right? And then we get a value of 0.625 after considering how frequent item Y is. And here we see the value is 0.6, and the basic rule here is if you see a value of 1, that means no association between X and Y. It's basically coincidence. If you see a value smaller than 1, that means it's unlikely to have those two appearing together. And if you see a value above 1, that means it's positive in terms of them likely to be brought together, right? So this is different than confidence. So sometimes it's a bit hard to interpret, but again, using layperson language, if you see a high lift, such as maybe a lift of 10, a lift of even a bigger number, it indicates it's not just coincidence. Because again, if you have a rule that has a high support, that has a high confidence, but still it can be coincidence. So the measure of lift is providing you a different measure to tell whether it's a coincidence to see something going together, or it's actually more interesting to look at. So those three measures are often used in association rule mining to help us find those most interesting rules that we want to look deeply. And with those measures, we can start to launch some algorithms in the arules package to help us find those frequent item sets or those association rules in the data set. And there, as I mentioned earlier, there are different algorithms for this. And one of the most popular algorithm is called a priori. And it's provided in the arules package. And what it does, it's basically looking for those item sets from the list of transactions you provide to the algorithm, and they're trying to find those frequent item set for you to look at. And here you see, as I mentioned, the function is called a priori. You fit your data, which has been created from the CSV file into this function. And here you provide a list of possible parameters you can provide to this algorithm. And here you see I'm telling this algorithm that I want the support to be minimal of 0.02. We want the confidence to be minimally 0.6. We want the maximum length to be 6, because sometimes you want to control for the length of those sequences. If you have really long transactions, if one transaction can contain many different items. So those measures or those parameters here are to help you fine-tune what you are getting from this algorithm. But this is our first attempt to find frequent item sets or rules from this data set. And here's the outcome, right? This is telling you this different kind of parameters you are setting. We're just using a few, and there's some others you see here that can be used in this call. And it tells you a bit more about how this algorithm is running, and give you a bit history about the process of running this algorithm. Maybe one interesting thing is you found 19 different rules from this process. And the next thing you can do after going through this, this process is to have a quick look at those rules you have. And here we can look at the first 10 rules, right? This association.rules is an object that was returned by the function. We can start looking to the first 10. And we can call the inspect function to which is coming from arules package that print out those rules in this nice table format for us to look at. And here, for every rule, you see there's a left-hand side and right-hand side column. And after that, it provides you those interest measures I mentioned. I mentioned support and confidence and lift. And then there's 2 additional columns. One is called coverage. Another one is called count. Count basically is how often those are appearing in the data set. And with that, we can start to look at, for every transactions, for those transactions, if math and physics appear, what's the chance of also having chemistry, right? So basically, this is identified as interesting and important association rules from this data set, right? If we see those 2 in one transaction, it's pretty likely we have pretty high confidence. And then the lift is bigger than 1 as well, right? The chemistry also be taken by the student, right? This list can go on and on. We can look at, for example, some other example. For example, the English, math, stats, and econ. If those 3 courses are selected by a student, it's pretty likely that econ or maybe economics will be selected as well, given this is has a pretty high support. We have pretty robust confidence, and the lift is bigger than 1, right? So we can start to look at those rules by just examining those identified frequent item set. And in the same time, we can also, if we have sometimes have a big list of rules, sometimes when I was analyzing a MOOC data set, the result could be hundreds of different rules or even thousands of different rules. One thing we can look at is to find, to make some queries into the rules that have been identified, so that, for example, we tell the algorithm that we want to see, we're interested in the course econ, right? We want to think about in which conditions the econ are selected by the students, in which combination of other courses the students are likely to select econ, using the same kind of data set. And we get this short list of rules that is focused on econ, right? And in a similar fashion, we can also tell the algorithm that we are now telling the algorithm that we have a thought on the left-hand side, the combination of math and physics. When students are selecting those 2 courses, what are the other courses the students are likely to select, right? It's another way of a round of the same question we asked about the econ question. And a priori algorithm can do the same. It can search for interesting transaction and return, in this case, only 1 rule that is associated with this left-hand side configuration. And you can do other types of tuning, as I mentioned. You can select those parameters, which we'll get into a bit later as well, to achieve different outcomes. And before I move forward, I want to mention this process is very iterative. It never happens to me that I run this once, I get something worth sharing to anybody else. It's very iterative. That means the first set of item sets or set of rules are usually not very meaningful. So you have to go back and forth in the process and to mobilize your knowledge about the domain and talk with experts in this area to really know what you're looking at and what's the best way to find the most interesting rules from the data set. And one important way to do that, as we have been doing in this module, is to look at some plots. And there are plotting functions built in arules that you can use. And here's, just called plot, and you can say the engine is called plotly. It's a JavaScript-based library, which makes your visualization interactive, right? So then you can start to look at this particular plot with x-axis representing support, y-axis representing confidence, and the color representing lift, right? So right away you can see, there maybe here you see a few different rules that have high lift, and in the same time it has pretty robust level of support and confidence. And versus here, even though they are identified as frequent item set, then the level of support and confidence is pretty low. Or some of the items here, the lift is lower compared to those other ones. So you can start to visually explore and interactively explore those different rules using this visualization. And the same thing, there's another possibility in terms of working with these rules. And there's another function that visualizes differently, which is a bit more complicated, but after I explain this, it should make sense. And here you see this is a graph with different things going on. This is a network, but there are two different kind of nodes in the network. First type of nodes you see, the circle nodes, they are the rules we identified from the association rule mining. And for every rule, if we kind of zoom into maybe rule number 9, you see there are the blue arrows. Let me move this. The blue arrows, including math, chemistry, and psychology, right? They're all pointing towards this rule 9. And then the rule 9 is pointing out towards physics, right? So this tells you how this rule is constructed. It's basically the left-hand side is a combination of the 3 different courses, and then the right-hand side is this one single course. And very similarly, the colors and size, they mean things so that you can visually interpret, right? Given the size of the circle, how confident you are, right? Given the color of the circle, what's the lift? What's the lift of this particular rule, so that you have another way to make sense of the rules you're getting. So again, you can use this different type of functionality provided by the library to explore the rule, and the goal here is to really find out what are the most interesting rules that's worth looking at in your data set. And as I mentioned earlier, it's very important to be able to select the the best possible parameters for the algorithm. And like some other data mining courses you're taking, it's usually an art to make good choices. Even though there are different researchers publishing papers about how to use those quality measures to make good judgment. I think we can definitely look into those possibilities. In the same time, I want to emphasize this is the iterative process. Usually we need to take a few different trials. We need to combine domain knowledge to make informed decision. And here, I think usually it's also helpful to look at how different parameters, if we combine them, could impact the number of rules we could identify from our data set. So in this example, I will not dive into the code itself too much because it's slightly more complicated, but it's going through a number of different parameters, right? We set up those different levels we want to hit, and we want to run this algorithm iteratively so that we get a collection of different sets of rules. And then we want to compare, if we choose a particular combination of the parameters, how our result might look like, how many rules we can get, and so on. right? So if we do that, following this code, again, it's a bit longer, and then we can start a plot. This is a simpler plot using the base R, but we can also do something more fancy using ggplot, which is part of the tidyverse. We get something like this. In this chart, as I mentioned, we have run that a priori function for many times using different configurations. And here, if we select confidence level, right, along this x-axis, and if we also configure the support level using those numbers, and the y-axis tells us how many different rules we will find. You can see that if we set the number too high, basically, if we set a number of confidence to be 0.5, and if we have this support level to be above 5%, we're likely to get 0 rules. That's not something we want to achieve. Versus if we set this too low, we get too many rules to make sense of. So this graph can help you sometimes to make informed decisions about what types of parameters you can use to achieve the best outcome. And again, this is an iterative process, but you have this approach of doing things multiple times thanks to the efficiency of the algorithm for this kind of mining of association rules. And with that, I want to stop here. And then in the next video, we're going to talk about frequent sequence mining.